I'm Jim Davis, editor and co-founder of Edge Industry Review. Today, we'll talk about laying the foundation for edge computing with Edge Datacenters. In 2022, Compass Datacenters launched a new business unit, Quantum, to deliver modular data centers for customers, adding incremental local, remote, or edge capacity. We're talking today with Tony Grayson, general manager of Compass Quantum, about how his company views the edge data center market evolving. Welcome, Tony.
Hey, Jim, thanks for having me.
So I want to talk a little bit first about how your edge data center construction process is differentiated from other modular data center providers. And I think it's just a really interesting process that you've told me about. So why don't you describe for our viewers what makes you different?
Yeah, I think, when I came on about, 18, 19 months ago, I really, kind of wanted to build upon our first previous generations and kind of the lessons learned that I had gotten from Schneider, Vertiv, Silent Blade Room, people who have been doing it a while. So I kind of really wanted to go, around 5 functions on the design. The first one really was sustainability. I really wanted something that was more sustainable than concrete and steel because they're all high carbon count. So, and unfortunately, there's not that many choices. We had to go with a composite for that. So we worked with a major manufacturer, develop a composite that was more sustainable, that gives you, in terms of savings, like 90 tons of savings compared to a steel structure. But another good thing about the composite, it's 100% recyclable. So we reuse all the dust and the material during the CNC process. And at the end of life, which is forever, really, you can actually recycle the whole thing. So it provides something a little bit different out there than your traditional steel or concrete. Second thing I really wanted to go after was, something strong too, something that's rugged, something that's not going to be blown away. And so once again, the composite can actually do a lot of that as well, where it can handle 250 mile an hour wind load. It's actually certified to be an F5 tornado shelter or a Category 5 hurricane shelter. It can handle up to 308 ballistic rating. We can actually, I think we go up to 9 millimeter now. The walls are at 75 psi. We can handle 105 psi on the roof. It's really built to last and be rugged. Because my kind of philosophy on that is, if you're putting $10 to $15 million worth of racks anywhere, why wouldn't you want to protect it? Why would you want to build it cheap or a way to get water in it or ruin your business that way? Next thing I kind of wanted to do was really, and I think this is what you're getting at, Jim, was I really wanted to use mass customization in the process to drive down costs, but also better time to market. And so I'm a big car person. So to me, what I've seen in the past with, kind of module construction or manufacturing, it's just been like a stick build in a building. So we've kind of separated our module into 6 pieces during a construction, during a manufacturing phase. At each phase, we have different things the workers are doing. So it's repeatable tasks. They do the same thing for each time. They have a certain amount of hours they're dedicated today. Managers come down to them. Quality comes down to them. And so they have all the tools right there. So, there's a reason why you don't have a company like Porsche with a bunch of people swarming around a car to build it, because it's super expensive to do that. And to be honest, the quality just isn't there. And so we're also trying to use the premise of kind of mass customization, meaning that it's like a Dell computer where you can't choose the case, you can't choose the motherboard, but you can choose everything else on it. So you can still customize, but that really drives down the price and increases the quality aspect of it if you standardize on a basic design and let customers to choose that. And then the last thing I wanted to do was I really wanted to have a software layer to control the whole thing. And so it's wonderful to have a sister company that works on DCM, BMS. We have a whole system that can remotely monitor and control the actual unit. So with one person, you can monitor and control 1,000 plus units. So that was the basis of what we're trying to get to, and where I think we're able to achieve everything within the next generation.
So what impact does that approach have on how long it takes to build one of your data centers and the total cost of ownership?
Yeah, right now, since we're standardized, we're mass customized, and we're using the same big pieces and parts, we could actually build it in weeks, assuming we have the parts, versus months. And then also we have designed a lot of it for permitting quickness too as well. Like, one thing I did forget to mention is we don't deploy on concrete pads, we deploy on piers. So, not only we can deploy it in weeks, we can actually install it in hours because we use peers, which means no geotech survey. I don't have to land grade. I don't have to do any civil permitting. We just screw the piers in and really put this thing on top. So it really gets you a quicker kind of time to market. In terms of, in terms of cost, I like to look at it more as a TCO. If you have a unit that is built out of composite that won't rust, that won't decay, and that you can always reuse if you need to, your TCO timeline is pretty long. So it really drives down those kind of TCO costs. Instead of looking at a time of life of maybe a module of 10 or 15 years, we're actually looking at hyperscale time of life, 40, 50 plus years with retrofitting. There's no reason why modules shouldn't be thought like that too.
So in terms of, say, an overall reduction in time from that initial purchase to manufacturing to installed on site, what have you estimated or seen in terms of the reduction in, getting one of these into the fields and installed?
Ideally, we'd love to have from PO to delivery. Now, we've yet to prove this is what my goal is. It's kind of like AWS or kind of like Amazon, where you order it and we can deliver it in 90 days, kind of on site. And now, granted, it's a lot that goes into that, and we're making a lot of assumptions that we can actually, the customer has the land, that the permitting will be easy. I mean, we're UL listed, but there's states like California, Oregon, and Washington that are just harder to deal with. But I think there's no reason why we can't do that from order to install in 90 days, as long as we keep the mass customization plan and the customer works with us on that.
So I think we've talked a little bit about this already, but what does the approach mean for customers that are looking to deploy edge data centers? Can you provide some numbers around the advantages in terms of, say, cost? Also, you were talking a little bit about the permitting time. How much time do you think they're going to save on that part of it in terms of the installation?
I mean, right now, so, as long as let's take the first one, which is the permitting time. I mean, it's UL listed as a piece of equipment. So the way the HA is considered, it's an unmanned piece of equipment. So no different than you putting a generator out there. That's the way they consider it. As long as I keep outside 6 feet away from a building, and as long as we don't have a certain square footage, and we can actually assemble these side by side, or we can actually grow them vertically, but there's ways we can do it so we don't violate that square footage. The AHJs don't consider it a manned piece of like a building, and to have those kind of same rules, or the fire marshal walkthrough. And the problem with that, it just adds in variability because they all view their own codes differently. And so you could actually go county to county, have the same code, and you have two HJs that consider it very differently. So we're just trying to minimize all of that kind of pieces and parts that can get into that. So that's why I think that the benefit of going with that is. And in terms of cost, it's tough to compare against, because we are providing on-prem, near-prem solutions. So I think if you look at cost of enterprise data centers, they are significantly more than a hyperscale data center. And we've seen retail sites per rack position, from anywhere between 3,000 to 15,000 per rack position. And we're somewhere between, and people don't like this number, $100 to $500 per kilowatt, because it depends on, do you want Tempest jacket? Do you want EMP rating? Do you want 50 cal ballistic rating? Do we have to do a bunch of different NRCs? I mean, so it varies wildly, but I think we're more expensive than a hyperscale, but cheaper than enterprise and retail than it's out there.
And describe your approach to enabling the day-to-day operations of an edge data center. How's this going to work for an enterprise customer?
Yeah, and so what we are trying to really do is take the concern of how do we deploy and operate, MEP or white space, if you will, from the customer. So, most businesses are built around the IP that goes inside of it, whether it's the servers, a software platform that uses all the servers to run something, or some kind of network like SD-WAN, like software-defined network. Not that many people are doing, the walls and the structure, if you will, or the box is just an enabler of that. And so it's kind of low priority for a lot of customers. And so what we're seeing is if what we're trying to really do is solve all those problems for the customer in terms of design. We actually front the cost to deployment and the day-to-day operations. We're just trying to do that in our MRR so they can focus on really the IP stuff. And we'd love that. We just want to put the company's name on the side of it. We don't even need our own name on the side of it. We just want to enable those HPC, those compute companies, those network companies to be successful. And we'll take care of the stuff that no one wants to do. It's kind of like a turnkey white glove service.
And so how does that differ from a traditional modular data center provider?
Yeah, it's different because we're doing an MRR under 3, 4, 5, 6, 7 year kind of terms, and where the customer can re-up, they can buy at fair market value, or they can walk away from it. I'm not building a bespoke data center. I think that just it breaks the mass customization process, and it just adds up costs. And from my opinion, it decreases quality. And I'm not saying that we're any better than any other modular company. We're just doing it differently. But I was able to, I've talked to all the leaders, Schneider, Vertiv, and all those companies who are doing it right now. And I think we were able to incorporate a lot of their lessons learned that they may not necessarily able to do because they're doing bespoke solutions for a customer. And we're not necessarily doing that. We're more about the mass customized approach. So hopefully I answered your question, Jim.
Well, I'm not sure if we touched on this earlier, but in terms of your business model, tell us how you're asking customers to invest in the edge data centers. You're talking to me about OpEx and turnkey model. You've also used the letters MRR. Maybe you can describe it a little more about how you see enterprises investing in edge data centers these days.
Yeah, I think right now you have some companies who are unsure what the future is, and so why not do an operating lease that doesn't count against your capital budget and that you can always walk away from in 4 to 5 years, and so you aren't making a wrong commitment. I think they've learned a lot of lessons from there's probably 100,000 plus telco huts out there that are concrete, so high not very sustainable, completely unable to be modernized or customized because they weren't built to go to like the 10, let alone 50, 60 kilowatt positions of HPC. So, really it's just kind of taking that risk out of it and just trying the operating model. But there's also a lot of companies that they're very good at software or servers. They don't really necessarily have an IT team or IT department, or if they do, it's a high cost. And so we're just trying to take all of those concerns out of it. And so, we will find a land, we will permit it, we will manufacture, we'll transport it, we'll install it, and we'll operate it for a customer, all under their terms. But we have our own 24/7, NOC, for lack of a better term, that we do security and monitoring on, and we can go with what the customer wants in terms of maintenance or smart hands aspect of it. But we're trying to just take all those problems away from a customer. And I do think, back from my time at Oracle, the MRR, kind of monthly option, it's a reason why hyperscale is doing so well. It provides a very good optionality for a customer, so they don't have to build their own business unit to be able to do it. And it may not matter if you're doing onesie twosies, but what if you're doing 1,000? What if you're doing 2,000 modules across the US? I mean, you're into past hyperscale money and cost, where we can get the capital probably easier than another company can.
So you mentioned telco huts. I'm just kind of curious, what are the notable use cases? Are selling these to telcos an option, or are there other use cases and deployment scenarios? What are you seeing in the market in the next 18 months or so?
Yeah, I think, everyone's kept on, everyone's been crying wolf forever. The edge is coming, the edge is coming. And I really, from my perspective, talking to customers, the edge is here. And it's probably not the edge as people originally thought, which is pushing compute out at the very far network edge. You can actually find edge in metropolitan areas right now. So, it's fallen in a couple areas what we're seeing right now. The first one is a hub spoke. So your first hub is your peering point on ramp. Your second hub is an aggregation point that's closer to that rural area or metro area that needs something more latency sensitive, compute move closer. And this is really partially being funded by BEAD in the United States, which is The U.S. is actually contributing $44.25 billion right now to improve broadband to rural areas and disadvantaged areas. So they're all building these aggregation points that are, 100 kilowatts up to the megawatt range. But eventually those have to spoke out into that rural area or metro area for IoT. So think smart cities, smart cars, any kind of local compute that needs to front haul to that first hub, and then which gets backhauled to the second hub. So that's kind of the first architecture we're seeing. So this is very different than kind of that hub spoke that's been in the past. It's there's no reason to move a peering on-ramp point if you can just build something compute closer. The second way we're seeing it right now is really, kind of the development. AI has really pushed this, but these HPC nodes. So it's customers that need HPC in a local area, whether it's privacy concerns or something else, or even they're just concerned about cloud costs. They want that. And hospitals are a great example of it, where, if you have an MRI, they can compare it against an MRI database and give you a prognosis to the radiologist. That would be a lot of data to move over the networks for a cloud. And you can actually, it's more cost effective to put something like that on-prem and just run that. But once again, we're talking 40 to 50 kilowatt racks, and the typical AV closet is not built for that. So we're starting to see kind of that HPC node aspect of it. The third way we're seeing it really is government needs, where the government is developing a tactical edge, if you will, or redoing their network to be more cloud and edgy focused. So you're starting to see a lot more government deployments. And that also comes down to federal and state deployments as well, as they try to have a more distributed architecture on their network. Another and the last one we're kind of seeing right now is this is probably it could be the biggest one, is actually I thought of another one, but the death of the AV closet. Like, we're getting to a point now in the architecture that you can no longer put these high density racks, and I'm talking 8 to 10 kilowatt standard compute in a closet right now. They need to go someplace else. So people are looking for on-prem, near-prem solutions. The only real choice they have right now is retail, but retail is about 1% free right now. So they're looking for some different solutions that are out there. So this is pretty much anyone outside of a hyperscale company. It could be a small enterprise company. It could be a big enterprise company. It could be a DR site. It could be for manufacturing. It's movie studios. Even malls have this kind of capability needs right now. And so we're seeing that aspect. And then I guess, and I mentioned the telecom, which we started off with. It's, the telecom's belief that fixed wireless or private network is the future. So they're invested heavily on deploying this infrastructure right now, but they can't use these older telco huts right now because of higher density needs of the racks, and so, or even the capital needs, to be honest. And so they're looking for partners to help them deploy that. And so instead of having a point like a box in the middle of a tower, you might have an aggregation point that's 4 to 5 towers that tends to be a little bit bigger than your traditional kind of telco hut. So those are all the customers I'm talking to right now. So to sum it up, it's pretty much anyone who has a computer. I'm talking to some form of that as a customer right now.
So in terms of the next 18 months, which one of those opportunities do you think is going to be driving your business this year and into 2024?
Yeah, I think right now it's the death of the AV closet, where customers need space right now, and the stick-built building data center is 2 years out, and so it's really a time to market play, and that also falls into the DR aspect of it as well. I think there's moving deployments to rural areas where there are not data centers, because we can build ours with a base load, so we're not necessarily tied to fiber and or power, where they're putting compute in local areas for, let's say, oil and gas, that kind of stuff. And to be honest, we're seeing a lot of military push as well, where they're trying to figure out how to deploy private 5G to bases or improve on-site data centers. So those are the top 3 customers that I'm talking to right now, but there's no shortage of customers out right now in this space, at least that I'm finding.
Well, that's good to hear, because certainly tech industry overall has gone through a lot of, I guess might call them convulsions, maybe a bit of a contraction over the last year with layoffs at all of the major players. And it certainly had its ripple effects, but it sounds like the groundwork is still being laid in a number of different ways for edge computing. So I wanted to thank you for your insights today, Tony. Appreciate it very much.
No, thanks, Jim. And hope I wasn't talking too much, but no, I appreciate the conversation.